Hello, viewer. Buckle yourself in because you're about to be blown away. Introducing Thea.
Since the beginning of civilization, navigation has been a crucial part of our day-to-day lives. It helps us travel from destination to destination, whether that be for business or for leisure. For most of us, it is easy as we can see what lies ahead of us with our eyes. Others are not so lucky. Because of this, the visually impaired need a safe, reliable, and hands-free solution to guide them around the world. Our solution is Thea.
Thea is a wearable, head-level obstacle detection device that will help the visually impaired navigate in public without the worry of head injuries. Have you ever hit your head and thought, hey, I really wish something had stopped me from hitting my head? Look no further, because Thea solves that. Thea will revolutionize the way the blind navigate. Long gone are the days of carrying a white cane or following a guide dog. Thea is composed of sensors, motors, and a computer, which are all conveniently hidden within a hat. When possible, Thea will be composed of recyclable components, and components that are non-toxic and biodegradable to comply with cradle-to-cradle design. The estimated cost for the proof of concept of Thea is roughly $350, with an additional $180 being added for the prototype and final product stages. The final product cost will therefore be roughly $530. The first of the two subsystems that create Thea is the machine vision subsystem. Thea will identify relevant street signs to the user through audio feedback.
In the video, the network is being run on a Raspberry Pi, and a webcam is feeding a video stream into the network. The estimate will be near 0 for no stop sign in the frame, and 1 for a stop sign present in the frame. As can be seen, when an image of a stop sign is raised towards the camera, the estimate goes from 0 to nearly 1, showing that the network is identifying that there is a stop sign in the frame. As the image of the stop sign is lowered, the estimate goes back down to 0, showing that the network is no longer identifying a stop sign in the frame.
The other part of Thea is the hardware subsystem. This consists of infrared proximity sensors, DC vibrational motors, and an accelerometer, all of which are processed using the single board computer, the BeagleBone Green. Once an object is detected, feedback will be provided to the user by using pulse width modulation on the DC vibrational motors. As can be seen, by changing the duty cycle, the intensity of the vibration changes as well. This will help convey how far or how close a given object is from the user. For our demonstration, however, LEDs were used instead, as showing the motors vibrating on camera would have been difficult.
Here you can see the first time the engineering journal was useful. Here you can see the engineering journal being swept across the field of view of the rangers. The LEDs light up corresponding to where the field of view was blocked, and the brightness of the LEDs corresponds to the distance to the obstacle.
Thea is designed to be worn on the head, so the user can move freely and comfortably. As such, it contains several rows of sensors that are activated according to the head orientation, detected by an accelerometer. Using the accelerometer, Thea can also detect sudden collisions or falls as a user. Then, a family member or emergency can be contacted depending on the user's preferences. Thea is a wearable device, so it is conveniently powered by rechargeable batteries.
I'd like to thank the teachers, my mom, and the boys for all their hard work. Shout out to Team-1 for all their hard work trying to impress them all semester. Time for some celebration.